Okay, here we are ready to start a new unit. We are going to be doing data analysis and probability. So let's go ahead and get started. Today we're going to be looking at sample spaces and outcomes and theoretical probability along with experimental probability. So let's see here. If we're thinking about probability, that's basically just the chances of something happening. So when we're calculating probability, the first thing to consider is all the possible outcomes of an event. Like an outcome is just what could possibly happen. Okay, so let's look at a couple of examples here. So if you're flipping a coin, what are the possible outcomes that you could get? Well, if you only have one coin, you're either going to get heads or you're going to get tails. Well, there's only two options there that you can have. If you're rolling a die, that would mean that your possible options would be if you rolled it once, you could get a 1 or a 2 or a 3 or a 4 or a 5 or a 6. Well, how many possible outcomes are there? There are 6. If you look at this spinner here, I don't know about you, but I would probably like to roll candy as what I would like to win off of that spinner, but I don't know. But it looks like there are 1, 2, 3, 4, 5, 6 possible outcomes. You could get a gum, toy, a hat, no prize, who wants that, candy, or fish. But there are 6 possibilities. Okay, another example here is asking a student which grade they are in high school. Well, you could either be a freshman, a sophomore, a junior, or a senior. So there are 4 possibilities. And the sample space is just the list of all possible outcomes for an experiment. So when we're talking about the sample space, we've listed that out on all of these. And when we're talking about how many outcomes there are, we've also listed that out there too. So if you're talking about theoretical probability, that's like saying what should happen, okay? And when you write the theoretical probability, if you notice right here is how it will look. Sometimes they'll say, ask the question, what is the probability of something? They'll put it into words. And sometimes they use notation. So like if they're asking about the probability of a 4 on a die or something like that, they might write it as P and then what you're looking to get, like the probability of a 4 or the probability of a red ball in a bag of green and yellow balls or something like that. So if you have theoretical probability, that means that you have a fraction. You always write probability as a fraction to start. So it's going to be how many desirable outcomes that you have out of the total outcomes that you have. So the first thing that you do, just like we did on the previous slide, is you list all possible outcomes and count how many there are, and then you circle just the desirable ones. Those are the ones that you're asking about or that you're wanting to get. So in theoretical probability, it's just what should happen, okay? Now, in the next couple slides here in just a minute, we're going to talk about experimental probability, where if you actually did the experiment, what actually happens. Theoretical is what should happen. And when you do it, it'll start out as a fraction, okay? Then you can turn that fraction into a decimal. And if it's a decimal, it should be between 0 and 1. And as a percent, then you just move that decimal 2 places to the right, and that gives you a percent. So it would be between 0 and 100%. So let's look at a couple of examples again. A bag contains 2 red balls and 3 green balls. Find the probability of choosing a red ball. Okay, so here I'm going to skip down for a second. Step 2 is asking us to find the probability of a red ball. So one way we could write that is probability of red. That's how you could put that. So let's go back up here for just a second, list all the outcomes and circle the desired ones. Well, what do we have in the bag? We've got a red and a red. We've got a green and a green and a green because we have 2 red and 3 green. Well, it's asking, so we have a total of 5, right? So we have a total of 5 possible outcomes. Oops. Okay. Then it says circle the desired ones. Well, what do we desire? We desire to get a red ball. Well, there's 1, 2 red balls in there. So we'd have a 2 out of 5 chance of picking a red ball out of that bag. So as a decimal, that's going to be 2 divided by 5, which is 0.4. So there's a 40% chance of choosing a red ball. Okay. A die numbered 1 to 6 is rolled. Okay, well, what are all of our possible outcomes? 1, 2, 3, 4, 5, or 6. Okay, now we want to think about, all right, how many total outcomes are there? There are 6 total. And the probability of an odd. So I'm going to put here, I'm going to say the probability of odd. Well, how many odds are there? 1, 3, 5. There are 1, 2, 3 of them. So the probability of rolling an odd number is 3 out of 6, which simplifies to 1/2. As a decimal, 1 divided by 2 is 0.5, or there's a 50% chance of rolling an odd number. Okay, and up here you may have seen this before. This is the probability scale, basically saying what's the likelihood of something happening. If you're down here at 0%, obviously it's impossible and it's not going to happen. And then over here on the far right is that it's 100% chance that it will happen. And then somewhere in between, halfway in between, 50-50, there's as good a chance that it will happen as not. And then there's all kinds of places in between. So one of the more common places that you see it, and right now with the weather being the crazy April weather that it's being right now, is we look at the Weather Channel and we want to know what is the chance it's going to rain, what's the chance it's going to snow. So we look, and on the Weather Channel it'll say things like, oh, there's a 20% chance of rain, or there's a 50% chance of rain, and you kind of gauge your outdoor activities or something based on the probability that it's going to rain or snow. So our question here is, the probability for rain on Saturday is 0.7 and Sunday is 0.6. When are we more likely to have rain? Well, I like to think in terms of percentages. 0.7 on Saturday is going to be a 70% chance of rain, and 0.6 on Sunday is or 0.65 is a 65% chance of rain. So Saturday has a better chance of rain than Sunday. Okay, you want to just pause the video here and try these on your own really quick, you can. If you just want to follow along, I'm just going to go through these really quickly. What is the theoretical probability of rolling a 4? So in notation, that's the probability of a 4. We already know that it's a number cube. A number cube is 6-sided die. That's just a fancy word for a 6-sided die. So we have 6 options. What is the probability of rolling a 4? Well, there's only one 4 on the die, so we'd have 1 out of 6. And so a 1 out of 6, we could also change that into a decimal, which would be 0.16 repeating, or 0.167, which is roughly 16.7%. And then the theoretical probability of rolling an even number on a number cube. So we have the probability of even. Okay, well, let's look at our numbers. 1, 2, 3, 4, 5, 6. Evens are going to be 2, 4, and 6. So that would be 3 options out of 6, which is 1/2, 0.5, 50%. All right, last one. Probability of a 5 or lower. Well, again, we have 6 possibilities. If we look up here at the numbers I already have listed out, 1, 2, 3, 4, 5, 6, it says a 5 or lower, which means we are going to include that 5, which means we are going to have 5 options out of 6, which is 0.83 repeating, which is about 83% chance of getting a 5 or lower. Okay, so next is experimental probability, where what happens if you actually do the experiment. So theoretically, if you roll a die 10 times or something like that, you'd get a 1 so many times. But if you actually do the experiment, what you think is going to happen doesn't always necessarily happen, because there's a lot of things that can come into play there. So when you're looking at experimental probability, it's the number of times the event occurs, how many times you got what you want out of how many times you actually attempted it. So like flipping a coin, or so say you flipped a coin 100 times, theoretically you should get a head 50 times and tails 50 times. But if you actually flipped the coin 100 times, you might get, 25 and 75. It kind of depends on a lot of things. So experimental probability is going to be a little bit different than theoretical. So like I've already said, experimental is actually doing the experiment and recording and tallying up things, and theoretical is what basically should happen if you did the experiment. Okay, so here we have a spinner. One of the favorite things, flipping coins, rolling dice, and spinning a spinner. Like those are what you see in probability problems all the time in math class. So here we have a spinner. And if you have paper copies of the notes, it might be kind of hard to see, but we have yellow, green, red, and blue. But the spinner was spun 20 times. Okay, so they are telling us we spun the spinner 20 times. The table shows the results. So let's just look at the results real quick here. If they spun it 20 times, that means they got red 5 out of 20 times, which would simplify to 1 out of 4, which is 25% roughly. Not roughly, exactly. If we did green 9 out of 20 times, okay, 9 divided by 20 is going to give us 0.45, or a 45%. 45% of the time they got green. Blue and yellow, blue is 3 out of 20, which 3 divided by 20 is 0.15. So they got blue 15% of the time, and they also got yellow 15% of the time because it's also 3 out of 20. So let's see what the question actually asks now that we've kind of calculated the experimental probability. For which color is the experimental probability of stopping on the color the same as the theoretical? Well, let's also think about over here on the spinner. So this was the experimental probability. They actually spun the spinner, and that's the results they got out of 20 times. Well, theoretically, if we are looking at the spinner, you have an equal chance of getting each one. So the probability of red would be 1 out of 4. The probability of yellow is also 1 out of 4. The probability of green, oops, that should say 1 out of 4 for the yellow, sorry. And then what color do I have left? Blue. The probability of blue is also 1 out of 4, because there is an equal chance that you would get any of those colors. So the question is, when is it the same? Well, if you notice, there's a 1 in 4 chance of getting red and a 1 in 4 chance of getting red with experimental and theoretical. So which color? Red. The theoretical and experimental actually matched up. All right, last one. This is kind of a lesson in you have to read the question carefully to make sure that you aren't just randomly using numbers that are in there. So in the United States, a survey of 2,184 adults aged 18 and over found that 1,328 of them have at least one pet. The types of these adults have, or the types of pets these adults have, are shown down in that graph there. What is the probability that a pet-owning adult chose a dog? Chosen at random has a dog. Well, the first thing we have to think about is, what is our denominator going to be? Okay, is it going to be out of all 2,184 people that they asked, or the 1,328 people that have a pet? Well, the question is asking what is the probability that a pet-owning adult has a dog. Well, the pet-owning adults are 1,328 of them, so your denominator is not going to be 2,184, it's going to be 1,328. So you have to read the question carefully. And then you look at your graph and you say, well, how many of those have dogs? Well, 916 have dogs. And if we divide out 916 divided by 1328, we get approximately 0.69, or a 69% chance that if you picked somebody at random, they would own a dog. So again, hopefully you have a little fun with some of this probability stuff that we're doing in this unit, and good luck.